Hello, 7th graders, and welcome to lesson 9.1. We are starting unit 10. As you can know, my slides look a little bit different here. For some reason, I don't have the original slides I had made a year or two back on this lesson, which is fine because online on our curriculum site, we also have this thing called Dynamic Classroom, which has the slides as well. So you should have the notes with you. Remember, those notes are just going to be in one big packet. Please keep the packet together. They're yours to keep. Do not rip them off and turn them back into me, okay? There will always be that code word though, so as you're going along, make sure you're watching for that code word. That shows me that you're actually paying attention and watching the videos. So what we're doing, and we're getting into statistics with this unit. I love talking about statistics, whether it's in data graphing, in representation, or talking about different kinds of numbers. So we're going to start kind of getting our mind ready to think about all those kind of things with statistics. And basically what statistics is you're organizing data, which is actually really relevant to what's going on right now with the world and COVID-19. And that everyone is trying to input all these data, points of data and trying to figure out what's going on, what's happening, okay? So with our notes here, I'm going to try and move myself a little bit so it's a little easier to see. Example number 1 says, you conduct a science experiment on house mice. Your teachers ask you what is the weight of a mouse? And here's your first question. Is this a statistical question? Okay, so let's think about this. You know about your statistics. Because you can anticipate the weights of mice will vary, it is a statistical question. So basically a statistical question is going to be something that measures something, okay? So giving this question, what is the weight of the mouse? You're going to expect that it's going to be a different answer depending on the mouse, okay? It's not going to be something like, what is the weight of a 10-pound bowling ball? Well, obviously they're going to be 10 pounds, okay? So you want something that's going to have a little bit of a leeway, but you're also not going to want something that's very clear and direct. Things like gender also aren't necessarily always a really good statistical question because you're either going to get one answer or the other unless you go into the realms of all the other kind of gender fluid things that people identify as. So then B, you weigh some mice and record the weights in grams in the table. So this is your graph of the weights of the mice. So maybe you went to a lab and you collected all this data, you measured all the mice, okay? What they want you to do is display the data in a dot plot. Identify any clusters, peaks, or gaps in your data. Now, we in 8th grade are also going to talk about these clusters and gaps, not necessarily peaks, okay? But we do talk about clusters and gaps. So it's going to be important that you understand what those mean. So when we set up a dot plot, we want to make sure that we set up a number line, and then we're going to put a dot above the number every time we see it. So in this case, like I see 21, 2, 3, 4. Looks like there's 5 20s in here. So when I make my number line here and I put in 20, I should have 5 dots above 20. All right, so let's see. So again, they say draw a number line that includes the least numbers, so from 18 to 28. So you don't need to include every single number, meaning like a whole bunch of numbers. You don't have to start at 1. You're just going to start with the lowest number and you're going to go up to the highest number. Then place the dot above the number line for each data set. So like I said, there was 5 20s in here, so I should see, there's 6 actually. I was wrong. 1, 2, 3, 4, 5, 6. Sorry, 6. So then you would have 6 dots above 20. Okay? So look here, 1, 2, 3, 4, 5, 6. Got it. So as you can see, they set up their dot plots. I want you to make sure that you set that up on your notes as well. Feel free to pause this at any point if this is going a little fast. I know it's a little harder when I just get to pull up the answers right away and I'm not writing them out. Again, it's just for this lesson what's kind of happen. So they set up the dot plot, and then they start talking about your clusters, your peaks, and your gaps. Gaps are easy to identify because it's going to be gap in your data. Okay, it's kind of like a gap in your line when we walk down the hallway, and I'm going to ask, why do I have a gap in my line? So where is there going to be a distance between the 2 points? Your peak is going to be the highest point, which I just happened to pull out, which was that 20, okay? So that has the most data on it because there was 6 different mice that all measured 20 grams, so that is your peak. And then your cluster is going to be where the most amount of data is. So this is why they put a cluster as kind of a circle here, okay? So most of the data is right there. So they say most of the data are clustered around 20, okay? So that's kind of how you could also explain your cluster. The peak is at 20, and the gap is between 23 and 27. They like to go from the smallest data point to the biggest when you talk about those gaps, okay? What are those distances in between there? They use the distribution of the data to answer the question. I'm not sure what they mean. Oh, so then they want you just kind of to use this and to describe kind of what's going on. So for the most part, you could kind of go, hey, you know, most of the mice are about 20 grams. Okay. So just making some of those connections, or you could say that, you know, in the general idea, most mice are between 18 and 22 grams. Otherwise, we've got some kind of chubby mice over here. All right, let's keep going. I'm going to pull this down just a little bit. We can't watch these extra examples, but if you ever want to, I believe you have access to this dynamic classroom in your big ideas. These are always fun to watch. My audio just will not pick up the video that we watch. All right. So on your own, I want you to go through this one, okay? So again, it's kind of the same thing. You're going to say, is it a statistical question? So are you going to expect a variety of answers? I want you to set up your dot plot given these ages. See if you can identify any clusters, peaks, or gaps. And then just come up with some conclusions about what you could say about the data. Okay, so go ahead, pause the video, take a minute to go through this. I'll check in with you here in just a minute. Alrighty, let's get back to it and we'll go through the answers. So the question asks, how old are people who retire early? So the question is it a statistical question? So are you going to expect there to be different answers? Is it this statistical question? Because you can anticipate the ages will vary, it is a statistical question, okay? Because it's not like, you know, like a good question that wouldn't be statistical is like, what age can you start driving? Okay, it's, you know, 16. What age are you allowed to start drinking? You're 21, okay? So people who decide to retire early can retire kind of whenever. And so that's why, usually once they're like 50 or 60 though. And that's why this is going to be a statistical question. So here is then your data plot, okay, or dot plot, sorry, and identify any clusters. So they are saying that there is a cluster. I would say your cluster is right around here between this 58 and 62, which is kind of about 60 because that's your peak as well. Because then they say the peak is 60, that's your highest data. Remember that you're taking this data and you would count up all the 60s, which also looks to be, well, maybe it's 5. 5 of them, okay? So you make a dot for every time you count 60. So there's 5 60s in here, that's why there's 5 dots. The gap then, there is a gap between 56 and 58. You could say there's a gap between these, as well as you could say there's a gap between 62 and 64. And then just kind of describing anything else. It says most people who retire early were about 60 years old. So again, it's kind of using that peak right now as kind of your mean or your average. And we're going to go into more of those kind of data measurements that you're used to seeing, which I know for the most part, most of you have learned those as early as 4th grade. So things like mean, median, mode, range. You might have even learned a few of them when you were in 3rd or 2nd grade, just depending on how easy they are. So we're going to review a lot of those and we're going to add some new things to it. So we're going to keep going. I believe we're moving on to example 2. All right, so here is example 2. Example 2 says you record the high temperatures every day while at summer camp in August. Man, guys, I can't read today. When you can, then you create the vertical dot plot. So you're at camp every day when you get up, or whatever. They tell you to measure the temperature every day at noon. So you go out, you record the temperature, you make this dot plot. Now you can make a vertical dot plot like this as well if you like those instead. I like this one because it's easy to read with the thermometer then. So then you create the vertical dot plot. So my first question, how many weeks were you at summer camp? So the way you're going to figure this out is because, so it's every week. Tricky question here. So every day you decided to record the temperatures at camp. So your biggest thing is you're going to have to count up all of these dots, okay? That will tell you how many days. But remember, the question is asking how many weeks. So we're going to have to convert it to weeks, okay? So when you count up all these dots, there is 28 data values. So that means that you are at camp for 28 days, okay? To convert this into weeks, we would need to think about how many days are in a week. There are 7 days in a week, so I'm going to take this 28 and divide it by 7. Okay, just like this. And I'm going to end up getting 4 weeks. So at this point, you've been at camp for 4 weeks, which is also about the same as a month at camp. So you could say 4 weeks, because they're asking weeks. So don't write months, don't write just days. They have to have weeks, otherwise your answer is not correct. How can you collect these? Can you collect this data? What are the units? So they're just asking, what are some ways you could kind of collect this data? Well, I was saying you went out and checked the thermometer. So you can collect data with a thermometer. And then for the most part here in the US, we collect things temperature-wise in Fahrenheit. So these are all in Fahrenheit measurements, but if you really wanted to, you could also measure it in Celsius. So they're just taking it almost back a step and having you realize how to do these kind of things, okay? Ask these statistical questions, how to measure things, what are you going to do to make this? It's kind of almost like an experiment. I feel like sometimes science and math go hand in hand, and I feel like this would be a good one for Mr. Condit to kind of explain too, with being an experiment and making sure you know what you are doing along the steps of your experiment. And then C, write a statistical question that you can answer using the dot plot. Then answer the question. So they didn't give us a statistical question. So they wanted us to come up with a statistical question. And how could we write a question that is something we could answer? So I'm not sure what they're going to come up with here, but I'm kind of thinking about this. And I could think maybe like, what is the temperature at camp? Okay. What is the daily temperature at camp? What is the daily high temperature in August? That's a good one too, okay? So one way you could explain that, well, you can look at your data, notice any clusters or peaks, or what do you seem to notice the most? So they say the high temperatures are spread out with about half of the temperatures at 81 degrees Fahrenheit and half the temperatures at 83 degrees Fahrenheit, or 86 degrees Fahrenheit. Okay, so since this data was pretty spread out, you could kind of explain something like that, saying, the most frequent numbers were 81 and 86, but they're spread out between about 80 and 87. All right. I'm going to need to pause this video. Please make sure to check out part 2 of this lesson. Please keep watching for your code word, because if you don't know what your code word is, not going to help you. So make sure you are watching this video, taking the time to ingest this, take it all in, okay? I will catch you in part 2. See you in just a minute.